Have you ever gazed at the night sky and wondered, how did all this space come into existence? It's a question that has intrigued humans for centuries, sparking curiosity and fascination. Let's take a journey back in time, over 13 billion years ago, when the universe as we know it didn't exist. There was only a singularity, an infinitesimally small point of infinite density and heat. Then, in less time than it takes to blink, it exploded. This colossal explosion, known as the Big Bang, is the moment of creation, the birth of the universe. In the aftermath of the Big Bang, the universe began to expand. It's not just that galaxies are moving away from each other within space, rather it's that space itself is expanding. Imagine a balloon being blown up. The surface of the balloon represents space. As the balloon expands, every point on its surface gets further away from every other point. That's a bit like what's happening with our universe. But how do we know all this? How can we study something that happened over 13 billion years ago? Well, scientists have a sort of time machine. It's called cosmic background radiation. This radiation is the afterglow of the Big Bang, a sort of echo from the early universe. By studying this radiation, scientists can learn about the universe's infancy, about its first moments. This radiation isn't just somewhere out there in the cosmos. It's everywhere, even here on Earth. It's passing through you right now. It's in the air we breathe, in the walls of our homes. It's a constant reminder of our universe's incredible origins. So, the next time you gaze up at the night sky, remember, you're looking at a history that stretches back over 13 billion years. Now let's delve deeper into the science behind the creation of space. Our universe's genesis, according to the Big Bang theory, is a singularity, a point of infinite density, temperature, and curvature of space. Imagine all the matter, energy, space, and even time compressed into a point so small it's almost non-existent. This singularity didn't exist within space. Rather, space and time as we know them were birthed from it. A little over 13 billion years ago, this singularity underwent a cataclysmic event, causing it to explode and expand at an unimaginable rate. This event is what we commonly refer to as the Big Bang. The Big Bang wasn't an explosion that occurred at some random point in space. In fact, it was space itself that was, and still is, expanding. Picture a loaf of raisin bread dough rising in the oven. As the dough expands, the raisins move away from each other, but not because they're propelling themselves through the dough. It's the dough, or in our case, space, that's expanding. This expansion is still ongoing, and it's accelerating. This means that galaxies are moving away from each other at an increasing rate. It's a bit like the raisins in our dough analogy, getting farther apart as time goes on. But what does this mean for us? Are we drifting away from other galaxies at breakneck speeds? Well, not exactly. The force of gravity within galaxies is strong enough to hold them together despite the cosmic expansion. So, while galaxies as a whole are moving apart, stars within a galaxy aren't. This expanding universe leads to some fascinating implications. It suggests that our universe may be infinite, as we can't find a definitive edge where the expansion stops. It also implies that the universe's age can be determined by retracing this expansion back to the singularity. In essence, the creation of space is an ongoing process, and we are part of this grand cosmic evolution. To sum up, the creation of space isn't a one-time event, but an ongoing process. Throughout our cosmic journey, we've delved into the mysteries that the universe holds and explored the science behind its creation. We started our voyage with the Big Bang Theory, the widely accepted explanation for the birth of the universe. This monumental event, which occurred around 14 billion years ago, was not an explosion in space, but rather an explosion of space. It was a singularity, a point of infinite density and temperature that expanded and cooled, giving birth to the universe as we know it. As we traveled further, we explored the concept of the universe's expansion. This is an idea that challenges our intuition. It's not merely galaxies moving away from each other within a static space. Instead, it's the very fabric of space itself that's expanding, carrying galaxies along with it. This expansion is happening everywhere, and it's happening right now. It's a phenomenon that's as fascinating as it is baffling. Our journey then took us to the cosmic microwave background radiation, the afterglow of the Big Bang. This radiation is a snapshot of the universe when it was just a few 100,000 years old. It provides us with a treasure trove of information about the early universe and the conditions that led to the formation of galaxies, stars, and eventually life as we know it. We encourage you to delve deeper into these topics, to question, to research, and to explore. The universe is a vast, complex, and beautiful place, full of mysteries waiting to be unraveled. Remember, the universe isn't just out there, it's also within us, as we're made of the same stuff as stars. So keep exploring, keep learning, and keep marveling at the wonders of space.